is D. Duran, Jr., and I wanted to share today with you a problem that I have found wrong, and that most people tend to believe that the way to solve a mathematical problem is the right way. Well, you know what I'm saying, but let me cut to the chase. I've asked a question on Yahoo Answers. I've asked them, how would you solve a mathematical problem? And before I begin, I would like to say that people rely too much on calculators. They rely too much on them to solve answers. They don't rely on the good old noggin. No, they believe in type, enter. That's the answer. They believe that. They type in a couple of numbers, and that's their answer. Well, I don't believe that. I believe learning by myself, and I also believe that I should teach myself, because really, that's how you really learn. When you teach yourself, when you're trying to see something that, oh, what is that? And you finally figure it out by yourself, you know it. You know it plainly and purely right here. That's how I think things should be done these days. Students figuring them things out for themselves, like I did. I may have not figured out everything by myself, but I've taken up to a point where I want to figure things out by myself. And I figured this out by myself. And I found a wrong problem to the way teachers have been teaching. And they teach these, the way I'm about to tell you, they teach students to do this in what they call a logarithm way. They use logarithms. As I got an answer that was posted on my Yahoo Answers. But anyways, here it is. Sorry. 2 to the power of x equals 10. Okay, before I get to this, pretend this 10 isn't here. Just focus on this part right here. Pretend this was still 2, and pretend we replace x with 3. What does 2 to the third power mean? I think, well, when you see a 3 above any number that is raised to a power, you automatically get a piece of paper out or on a calculator and type in 3 2's. As in this case, you would type in 3 2's or write down 3 2's and multiply the 3 2's all together. And I know you get like 8, but this is not the case right now. So you would get 8, of course. But mainly what I want to focus on is on this part right here. Whenever you see a number raised to a power, and it has a little bitty number written above it, people would automatically say, oh, that's 3 2's. Oh, that's 3 2's multiplied by each other. Well, that's right. But what many people fail to understand is, I've noticed this, is on this problem right here. Now, how would you solve this problem? I've got many answers and said to use the logarithms. I don't believe in that. I believe logarithms give a false answer. And I want to prove to you what I believe is right. As you can see, I did quite a bit of work here. Let me zoom in for you. I'll bring this up closer. As you can see, 2 right now is being raised to a power of x equals 10. Now, initially what I would think is, well, how would you figure out what x is? 2 raised to the power of x equals 10. How would you figure that out? How would you figure out what x is when 2 raised to the power of x equals 10? What I did was like, well, in order to get 10, we would have to write out, we can take 3 2's out of a 10, and you get 8, but that's not 10. If you take out 4 2's, that'll give you 16, and that's not 10. So you can't take out 3 2's because it's less. It's not 10. And you can't take out 4 2's because it's more. So there has to be something that multiplies to the 3 2's to help them equal 10. Because 3 2's alone will not equal 10. 4 2's is just too much. So you have to have a partial answer. And it is not 2. It's not another 2. It has to be another number that multiplies to give you 10. And that number is 1.25. 2, 1, 2 times another 2 times another 2 times 1.25 will give you 10. It'll give you 10. Nothing to it. And most people would answer this when you're looking at this and you would say, well, he's wrong. People would say the real answer is 3.321, etc., etc. My real answer is this, 3.625. You enter that into a calculator and you get 12 point something. The calculator's wrong. Remember we were talking about the little number right here? For instance, you have, for like I said, you have 3 2's. But let's go back to this part right here. Let's pretend again that 2 is raised to the power of x. It's raised to the power of 3. 2 to the power of 3. And let's say let's write it out. 2 times 2 times 2. How would you write that in exponential form? Well, there's 3 2's, right? So that's 2 to the power of 3. 2, 3. The little number on the top 3. Because it's 3 2's being multiplied by each other. So it's already 2. Here's what I did for you. This is what I feel. See? Right here? Here's how I see things. Here's 2 over 2, 2 over 2, and 2 over 2. Ignore this right here. 2 over 2 plus 2 over 2 plus 2 over 2 is 1, right? Because it's 3 2's that multiply, that equals 2 to the raised to the power of 3. If this is like we said, we substitute this for 3. If this is 3, then it's 2 times 2 times 2, right? If it's 3, then it's 2 times 2 times 2. And there's 3 2's, right? So each 2 represents a 1 plus another 2, which is 1 plus another 2, because there's 3 2's multiplied by each other. And to get an exponent out of those 3 numbers of 2, to get an exponent, you have to add them together. 1 2 is represented as 1, and the other ones are represented as 1. Since there's 3 2's, there's 3 numbers, and that's where you get 2 raised to the power of 3, because you write 3 2's down and multiply them together, and each 2 represents a 1 when written in exponents. You have 3 2's, and that makes 2 raised to the power of 3. Hence, 2 raised to the power of 3 when you have 3 2's that are multiplied by each other. In this case right here, in that case right there, it is really that. It is really that. So the real number to actually get 10, 2 times 2 times 2 times 1.25, and that's how you get 10. Remember, like I said, each 2 is represented as a 1, because, like I said in the previous one, 2 raised to the power of 3 is 2 3's. So if you really think about it, it's like 2 over 2, because it's really just 1. It's just like 2 is represented as 1. So 1, 2, 3. Remember how I said you can take 3 2's out of 10, but that's not quite it. And that's right, you can take 1. Here's 2, 2, and 2. 2 divided by 2 is 1, because that's 2 over 2 is 1. 2 over 2 is 1, 2 over 2 is 1. You can take 3 2's. You can take 3 2's out of 10, but you get 8. That's not quite enough. Remember that other number we had to say? This one right here? It's right over here. 1.25. You put this one over 2, just like you did all these right here. And since out of all these you got 1, 1 plus 1 is 1, 2 raised to the third power. Out of all these you got 1. What can you get out of this one? 0.625. Or 5/8 of a 2. It's not a 2, but it's quite a 2. It's not quite there, but it's a partial 2. And you add that to that number. And you add it to the 3 2's. 2 raised to the third power is not it. If you add the 5/8 of a 2, it's 2 raised to the 3.625 power. Why do I say that, and why do I get a different number than other people with using logarithms, getting 3.321? Because they're doing it wrong. It's incorrect. We interpret the number on top of the x. We interpret this right here wrong. We automatically say, oh, there's a decimal, it must be different. No, it's nothing different. So this is right here. That's the right number. Why? Because see that power right there? Well, let me write it down for you. See what I wrote right there? That's the right answer. Why? Because remember, see that little 3? Ignore the decimal. Ignore this one and everything after the decimal. Ignore the decimal and everything after it. So just ignore it. So cover that up. Remember how I said it? Remember what I said? There's 3 2's, right? There's 3 whole numbers. See? 3 2's, right? You write out 3 2's, right? So you just write out 3 2's. Ignore the decimal and everything after it. Just concentrate on the 3. So you would write 3 2's out. 2 times 2 times 2. That gives you 8, right? But there's something else missing. The 0.625. How do we get from... So 0.625 times 2 times 2 times 2 is not 10. But you got to remember, we're not really asking 2 raised to the power of 2 times 2 times 2. We added the 2's together because they all represent 1. And that's how we got 3, because it's 3 2's multiplied by each other. But we forgot 3 2's plus a part of a 2. It's not a 2, but it's 1.25 over 2 to get 10. So we'll write 2 times 2 times 2. And then we have a 5/8 left, or when we have 0.625 left. So how do we get that into something that'll multiply to 10? Well, since we divided it by 10 to get 0.625, we multiply 0.625 by 2 again, and you get 1.25. So you take 2 and a 2 and a 2, 3 2's multiplying together, then multiply 1.25 and you get 10. And to get them back to an exponent, you have 3 2's, right? So it's 3. 2 raised to the power of 3, point, that 1.25. But you got to get that into a exponent form, so you put it over 2 because it's not a 2. It's not all the way a 2. It's a part of a 2. Sort of like a fraction. Like when you eat, like there's 8 slices of pizza and you eat 7 of them, it's 7 over 8. You didn't eat them all, but it's still pizza. But this is 2's. You only ate like part of that 2, and you only have 1.25 left. That's how much you have left. 1.25 over 2, and you get 3.625. The reason it's 3.625 is because 2 3's are multiplied. 3 2's, excuse me. 2 3's, 3 2's are multiplied by each other. So again, that's 2 times 2 times 2, right? Because it's 3 2's, right? Ignore everything after the decimal. 3 2's, right? 2 times 2 times 2. Then you look at the decimal, 0.625. Remember, each 2 is represented as a 1. It's 2 over 2. It's 2 over 2, which is 1. 2 over 2 plus 2 over 2 plus 2 over 2 is 3. And that's where we get 2 raised to the third power. And then plus that 0.625. Since 0.625 is really 1.25 over 2. So it's 1.25 times 2 times 2 times 2, and you get 10. You get 10. That's the right answer. So this